Okay, Wildcat. So we're going to 5.3 solving quadratic equations by taking square roots assignment tutorial. Question 1. Solve the equation x squared minus 9 equals 16 using the indicated method. Solve by graphing. So we're going to use Desmos. So step 1, we're going to graph y equals x squared minus 9. And step 2, we're going to graph y equals 16. So let's do that now. Okay, so y equals x squared minus 9. And y equals 16. Okay, now you're going to come over here. And you can either zoom out or move the graph until you see the two intersections. Click on the points, and the solutions are the x values of the intersection. Okay, so first off, you can see that this graph matches. Okay, that should be pretty simple. And then identify the coordinates of the point where the two graphs intersect. The coordinates are 5 and negative 5. Okay, now part 2, we're going to come over here, and we're going to solve x squared minus 9 equals 16 by factor. Okay, so if we're going to factor, we first need to subtract 16 from both sides. You need everything on one side to solve by factoring. So then that's x squared minus 25 equal to 0. Okay, now this is a difference of squares, so we know that this is x minus 5 times x plus 5 equal to 0. Okay, so we have x minus 5 equal to 0, x plus 5 equal to 0. Here we're going to add 5 to both sides, so x equals 5. And we're going to subtract 5 from both sides, so x equals negative 5. Okay, all right, let's go and take a look at part 3. Okay, part 3, we're going to solve x squared minus 9 equals 16 by taking square roots. So we're going to add 9 to both sides. So x squared equals 25. We're going to take the square root of both sides, so plus or minus. Okay, so when you take the square root of squared, that cancels, so you're left with x equals, the square root of 25 is 5, so that's plus or minus 5. All right, let's take a look at the next question. Okay, question 2. Solve the equation 2x squared plus 1 equals 9 using the indicated method. So we're going to solve by graphing. So step 1, we're going to graph y equals 2x squared plus 1. And step 2, we're going to graph y equals 9. So let's do that now. So we can just delete here, y equals 2x squared plus 1, and y equals 9. Okay, click on the point of intersection. Don't click on that. I don't know why that's there and this point. So our x values are negative 2 and 2. Okay, x equals 2 and negative 2. All right, part 2, solve 2x squared plus 1 equals 9 by factoring. So we're going to subtract 9 from both sides. Okay, so then you have 2x squared minus 8 equals 0. Now, we can factor out a 2 from both terms, which leaves 2 times x squared minus 4 equal to 0. Now, x squared minus 4 is a difference of squares, so that factors to be 2 times x plus 4 times x minus 4 equal to 0. Now, we're going to divide both sides by 2. So then you're left with x plus 4 times x minus 4 equal to 0. Set them each equal to 0, so x plus 4 equal to 0, and x minus 4 equal to 0. So we subtract 4 from both sides, so x equals negative 4, and we're going to add 4 to both sides. So x equals 4. Okay, let's look at part 3. All right, part 3. Solve 2x squared plus 1 equals 9 by taking square roots. So here we're going to subtract 1 from both sides. We have 2x squared equals 8. Divide both sides by 2. So x squared equals 4. Take the square root of both sides, plus or minus. So this cancels. You're left with x equals plus or minus 2. Okay. All right, let's take a look at question number 3. Okay. Question 3. Solve the quadratic by taking square roots. So we're going to divide both sides by 8. Okay. 8 divided by 8 is 1. You get x squared equals 40 divided by 8. Okay. Now, we want to reduce this, okay, probably first. We want to figure out what 40 divided by 8 reduces to be. So we got to think about what we can divide both of these numbers by. Well, it looks like we can divide both of these by... Actually, you know what? I think 40 divided by 8 actually reduces. I think it's even easier than that. Let me try. Let's go to Desmos calculator. Scientific calculator. 40 divided by 8 is 5. So it's even simpler than I thought. So x squared equals 5. Okay. Take the square root of both sides. Well, this cancels and you're left with x equals plus or minus the square root of 5. All right, let's look at the next question. Question 4. Solve the quadratic by taking the square roots. So we need to subtract 12 from both sides. Okay, this becomes 0, so now you have negative, I'm going to put a 1 there, x squared divided by 6 equals negative 12. Okay. Now, we want to get rid of the denominator, so we're going to multiply everything. And in fact, let's do this all in one. We want to get rid of also the negative and the denominator, so let's multiply everything by negative 6. Okay. Now, negative 6 times... Give me. I apologize for sneezing. All right. Negative 6 times negative 1 is a positive 6x squared divided by 6 equals negative 6 times 12, negative 12. And let's just make sure I don't make a mistake when I multiply. Negative 12 times negative 6 is 72. Okay. 6 divided by 6 is 1. So you have x squared equals 72. Okay. We're going to take the square root of both sides, plus or minus. Okay. So this cancels. We're left with x equals, you know it's going to be plus or minus. But now we need to see if we can reduce the square root of 72. Okay. So what I'm going to do is, over here, I'm going to go to Desmos, graph, and table. Okay, function table. Let me delete this and then delete these values. And I'm going to find all the combinations divided by 72 divided by x, and a perfect square. So 1 doesn't help us. 4 works, it reduces it, but let's see if we can go further. So let's try 9. 9 goes even further, and let's try one more. Let's go to 16. 16 doesn't work. Let's try 25. Let's try 36. 36 is the best. That's as reduced as it's going to be. So now let's rewrite 72 as 36 times 2. Now, you can, when you have multiplication on the square root, you can take the square root times the square root of that number. So we have x equals plus or minus the square root of 36 times the square root of 2. And the reason we did that is because now we can take the square root of 36 as 6. So x equals plus or minus 6 square roots of 2. Okay, and that is our answer. All right, let's go and take a look at the next example. Or I'm sorry, question. All right, question 5. Solve the quadratic by taking square roots. If necessary, rationalize the denominator, enter the answer in simplest form. So first we need to distribute 5. So 5 times 8 minus 8x squared is 40 minus 40x squared equals 8. Okay, now we're going to subtract 40 from both sides. So negative 40x squared equals negative 32. Okay, now we're going to divide both sides by negative 40. Okay, so this divides becomes 1. So then you have x squared equals, a negative divided by negative is positive, so that's 32 divided by 40. Now we want to see if we can reduce that. Okay, now we think about what numbers can go into 32 and 40. Okay, well, the answer to that's 8. So we can actually write this as 8 times 4 is 32, and 8 times 5 is 40. Okay, that helps us because 8 divided by 8 is 1, so this is equal to 4/5. So instead of trying to work with the 32 divided by 40, now we can work with the 4/5. So we have x squared equals 4 divided by 5. Okay, we're going to take the square root of both sides, plus or minus. Okay, so then x equals plus or minus the square root of 4 divided by square root of 5. Okay, now the square root of 4 is easy, that's 2. So x equals plus or minus 2 divided by the square root of 5. Okay, but you never leave a square root in the denominator, so we need to multiply this by square root of 5 divided by square root of 5. So that's plus or minus 2 square roots of 5 divided by square root of 5 times square root of 5 is 5. So x equals plus or minus 2 square roots of 5 divided by 5. Okay, let's take a look at question 6. Okay, solve the quadratic by taking square roots. Okay, so we're going to add 8 to both sides. Okay, so you get 3x squared equals 20. Divide both sides by 3. So you get x squared equals 20 divided by 3. Take the square root of both sides, plus or minus. Okay, so then that cancels, you're left with x equals plus or minus the square root of 20 divided by the square root of 3. Now the first thing is we don't want a square root in the denominator. So we're going to multiply both by square root of 3, square root of 3. Okay? Now, whenever you have a square root times a square root, you can actually multiply these together. So this is equal to plus or minus the square root of 60. Square root of 3 times square root of 3 is 3. Okay? So now we have x equals plus or minus. We need to see if we can find a perfect square that goes into 60. So come back to the function table. Okay, and we're going to take 60 divided by x. So we're dividing by perfect square. So 1 works, but we want to reduce as low as possible. So 4 works. Let's try 9, and then 16, 25, 36, 49, and then 64. So once you get larger than the number, then you know to go back, and so our combination is 4 and 15. Okay, so we can write the square root of 60 as 4 times 60, or I'm sorry, 4 times 15. Okay, divided by 3. Well, you can write that as plus or minus the square root of 4 times the square root of 15 divided by 3. Well, the square root of 4 is 2, so this is plus or minus 2 times the square root of 15 divided by 3. Okay, so we would say that x equals plus or minus 2 times the square root of 15 divided by 3. All right, let's take a look at the next question. Question 7 of 15. Solve the quadratic by taking square roots. Allow for imaginary solutions. So we need to take plus or minus the square root of both sides. Okay. Now, this cancels. You're left with x equals, when you take the square root of a negative number, it's imaginary. The square root of 25 is 5, so the square root of negative 25 is 5. Oh, almost forgot. Plus or minus 5i. Okay, let's take a look at the next question. Okay, question 8. Solve the quadratic by taking square roots to allow for imaginary solutions. X squared plus 16 equals 0. So we're going to subtract 16 from both sides. Okay, x squared equals negative 16. Now we're going to take the plus or minus square root of both sides. Okay, this cancels. You're left with x equals plus or minus. The square root of 16 is 4, but since it's negative, it's I. So square root is plus or minus 4i. Okay. Let's take a look at question 9. Solve the quadratic by taking square roots. Allow for imaginary solutions. Enter your answer in simplest form. Okay, so first things first, we're going to add 5 to both sides. So you get 5x squared equals negative 12. Okay, divide both sides by 5. So you have x squared equals negative 12 divided by 5. Now we need to do plus or minus the square root of both sides. Okay, so that cancels. You're left with x equals plus or minus the square root of negative 12 divided by the square root of 5. Okay, now we need to see if we can rewrite, well, first off, I'm sorry, we need to multiply everything by the square root of 5. We can't have a square root in the denominator, okay? So then this equals plus or minus the square root of Negative 12 times 5 is negative 60, divided by square root of 5 times square root of 5 is 5. Okay, so x equals plus or minus, we need to see if we can reduce 60. Okay, so we come over here and delete here. Well, we already have 60, so we just change that to negative 60. And we do 1 times, and then 4. We know that 4 negative 15 was the smallest. So 4 times 15, or I'm sorry, negative 15. Okay, divided by 5. Well, then we know that's x equals plus or minus the square root of 4 times the square root of negative 15 divided by 5. Well, the square root of 4 is 2, so plus or minus 2. And then we know the square root of negative 15 is I, so this is the square root times the square root of 15i divided by 5. Okay. All right, question 10. Okay, solve the quadratic by taking square roots. Allow for imaginary solutions. Enter answer in simplest form. Okay, so we're going to subtract 10 from both sides. So you get 7x squared equals negative 10. Okay, divide both sides by 7. Okay, x squared equals negative 10 divided by 7. Okay, now we need to take the plus or minus square root of both sides. Okay, so that cancels. So then you get x equals plus or minus the square root of negative 10 divided by square root of 7. Now remember, you can't have a square root in the denominator, so we need to multiply this by square root of 7. Square root of 7. So square root of negative 10 times square root of 7 is the square root of negative 70 divided by square root of 7 times square root of 7 is 7. Almost forgot the plus or minus. Okay, so then x equals plus or minus. We need to find out how we can reduce the 70. So we now have negative 70. And so let's try all the squares. So 1, 4, 9 doesn't work. 16, nope. 25, nope. 36, nope. 49, nope. 64, and then 81. Once you get past the number, then you know there's nothing you can do. So this is plus or minus the square root of 70. You're taking the square root of negative, so it's I divided by 7. Okay. Let's take a look at the next question. All right, question 11 and 15. Determine whether the quadratic equation real solutions or imaginary solutions by solving the equation. Enter your answer in simplest form. Okay, so we're going to add 7 to both sides. So you have 14x squared equals 7. Divide both sides by 14. So you have x squared equals, now this is simple because 7/14 reduced to be 1/2. Now we take the square root, plus or minus, of both sides. Okay. So this cancels. You're left with x equals plus or minus the square root of 1 divided by the square root of 2. Okay? Now we need to multiply by square root of 2 divided by square root of 2. Okay? So that equals plus or minus the square root of 2 divided by 2. There's nothing else you can do with that. So we would say x equals plus or minus 2 square root of 2 divided by 2. Okay? All right, let's take a look at the next question. Okay, question 12 of 15. Determine whether the quadratic equation has a real solution or imaginary solution by solving the equation. Okay? 1/2 x squared plus 12 equals 4. So we're going to start by subtracting 12 from both sides. So that becomes 0. So then you have 1/2 x squared equals negative 8. Now we need to get rid of the fraction, so we're going to multiply everything by 2. So 2 times 1 is 2x squared divided by 2 equals negative 8 times 2 is negative 16. This divides and becomes 1, so you have x squared equals negative 16. Take the square root plus or minus of both sides. That cancels. X equals plus or minus the square root of negative 16 is 4i. So x equals plus or minus 4i. Because it has I, the solutions are imaginary. All right. Question 13 of 15. Determine whether the quadratic equation has real solutions or imaginary solutions by solving the equation. Enter your answer in simplest form. Okay, so we need to distribute the 6 and the 5, so that's 12x squared minus 24 equals 5x squared minus 40. Now you need the x squareds on one side and numbers on the other. So it's always a good idea to subtract the smaller x squared from both sides. So let's do that. This is 0. So then you have 7x squared minus 24 equals negative 40. Add 24 to both sides. Okay, you get 7x squared equals negative 16. Divide both sides by 7. So then you have x squared equals negative 16 divided by 7. Take plus or minus the square root of both sides. Okay, that cancels. X equals plus or minus the square root of negative 16 divided by the square root of 7. Now we need to multiply both by square root of 7 by square root of 7. Normally, I would multiply these together to try to reduce, but we know that the square root of that is, okay? So the square root of negative 16 is plus or minus 4i, and then that's just times the square root of 7. Okay? The square root of 7 times square root of 7 is 7. Now, when you put this in HRW, they're going to put the I in the back. So then that's x equals plus or minus 4 times the square root of 7i divided by 7. Since there's an I in the answer, the solutions are imaginary. Okay, let's take a look at the next example, or question, sorry. All right, question 14 of 15. Determine the lengths of the sides of the rectangle using the given area. Give answers both exactly and approximately to the nearest tenth. The area of the rectangle is 28 centimeters squared. The length is x, the width is 4x, okay? To find the area, we know that length times width equals area. Okay? Now, the length is x, the width is 4x, and the area equals 28. Okay, so now we're going to solve for x. So x times 4x is 4x squared equals 28. Okay, divide both sides by 4. X squared equals 6. Let me double check. It's always a good idea to check your multiplication or division to make sure you don't make a calculation error. So 28 divided by 4 is 7. So look at that. Almost made a mistake. So x equals 7. Or x squared equals 7. So again, it's always a good idea to check your calculations. So now we take the square root of both sides. So plus or minus the square root of x squared equals plus or minus the square root of 7. So that cancels. You're left with x equals plus or minus the square root of 7. Okay. Now, the width is 4. So let me put this. The width is 4x, and the length is x. Okay. So we can come right here. The length of a rectangle is the square root of 7. Okay, which, let's use Desmos to get that. And they say to the nearest tenth, so 2.6. Okay, so the length of the rectangle is approximately 2.6 centimeters. Okay, now the width we need to multiply 4 times the square root of 7. So four times the square root of 7, which 10.6 centimeters. Okay. All right, let's go ahead and move on to the last question. Okay, question 15 of 15. The aspect ratio of an image on a screen is the ratio of the image width to the image height. An HDTV screen shows images with an aspect ratio of 16 to 9. If the area of an HDTV screen is 432 inches squared, what are the dimensions of the screen? If necessary, round to the nearest tenth. Step 1. The width of the screen must be some multiple of 16 and the height of the screen must be some multiple of 9. Step 2. Let m be the common positive multiplier so the width is 16m and the height is 9m. And the ratio of the width to the height is 16m divided by 9m, which is 16 divided by 9. And the width times the height equals the area of the TV. So we know that 16m times 9m is 432. Okay. Step 3, we're going to solve 16m times 9m equals 432 for m. So let's first multiply 16 times 9. Is 144. So 144, m times m is m squared equals 432. We're going to divide both sides by 144. Okay. So this divides and becomes 1. So m squared equals, let's do 432 divided by 144 is 3. Okay. So now we take the plus or minus the square root of m squared and plus or minus the square root of 3. So m equals plus or minus the square root of 3. So the width of the screen is 16 times the square root of 3, which is approximately, and they want it to the 10th, so that would be 27.7 inches. And the length of the screen is 9 times the square root of 3. Notice that we didn't use a negative because you only use positive dimensions. So we would say that m equals is the positive square root of 3. We don't use negative when we're talking about dimensions, okay? So now we do 9 times the square root of 3 is 15.6. Okay? All right, if you would. Hopefully this will help to complete your assignment. And with that, have a wonderful Wildcat day.